Okay, today I'm just going to talk a little bit about an extension from last week, which we were talking about algebra and rearranging to solve for x. This week, what we're going to do is start looking at changing those variables from numbers that we know into letters or variables and figuring out how it works. And you'll find out that it works very similarly. So we would encounter situations such as x plus 3 equals 8. And I would ask you to solve for x. And solving for x, a lot of you would probably say intuitively look at this and say, okay, what plus 3 equals 8? And a lot of you would say 5 off the hop. If I were to ask you to show how to solve this through a process, what you might do is say, okay, we want to isolate x. We want to get x by itself. So we have plus 3, and we want to apply the opposite operation. So the opposite of adding 3 would be subtract 3. However, remember, this is like a scale. If I subtract 3 from one side, I must subtract 3 from the other side. So let's go ahead and do that. And then we could solve. Well, we have x plus 3 minus 3, and that just cancels out to give us 0. So we are left with x on this side is equal to 8 minus 3 is 5 to get our answer x equals 5. Now, the reason I show you this, and a lot of you could probably look at this and say, oh, it's 5 right off the hop, but this is a trivial example so that we could lead into something such as, if I gave you a question like this, x plus a is equal to b. Now, before you freak out and ask, well, how do we solve this question? I might ask you to isolate for x and say, solve this question so that you have x by itself. Well, we could apply the same methods we used with numbers, just with our variables. If I had plus a, doesn't matter what a is, we could get rid of a, right? We could subtract a from a, right? If we have a, whatever it is, and we take away a, right? A minus a would just equal 0, right? You have an a, you take it away. You do not have a anymore. However, again, we're going to apply the same concept we had over here. If we subtract a from one side, we must subtract a from the other side. So I'm going to write subtract a over here. Well, this side just isolates for our x, like so. And this side we will have b minus a. So let's just write that out. B minus a. We have isolated for x, and this would be our solution. It does not need to have a number attached to it at any means. However, this is our final answer. Okay, so again, we're just applying the opposite operations. We want to get x by itself. So similarly, when we're talking about addition and subtraction, we could talk about multiplication and division. Giving a division question where I have x divided by 5 is equal to y. Well, I ask you to solve or isolate for x. Get x by itself. And we have this number here, right? If we divide something by 5, we could apply an opposite operation in order to solve for it. So the opposite of divide by 5 would be multiply by 5. So I'm going to multiply this side by 5, where we have 5 times x divided by 5, which that's going to cancel out because 5 divided by 5 is going to give you 1. However, if I multiply one side by 5, I must do the same thing to the other side because we want to keep our scales equal. So I'm going to multiply this side by 5, leaving us with, well, this cancels out, leaving us with x, or 1x technically, but a lot of times in math we just drop the 1. So we have x equals to, and on this side we have y times 5. Another way we could write that is 5y. Remember, when two things are next to each other, that implies multiplication. So again, as long as we apply this idea of opposite operations, we could solve any amount of questions. So furthermore, if I ask a question, let's mix it up a little bit. 2x plus a equals b. Now I have a question like this, and I ask you, isolate for x, solve for x. And And we're not going to get a traditional answer like we did in this first one, but it's going to look a lot similar to this second and third question. Let me label my questions so that I could refer to them later. Here. So on question 4, if we were to add a, the opposite of adding a would be to subtract a, because we want to get x by itself, and this a over here, we want to move to this side somehow. And in order to do that, again, similar here, we have add a, so we took away a. So let's get rid of this a by subtracting a from both sides, and subtract a. Now I'm going to rewrite my equation. So it's 2x plus a minus a, which gives us 0. I'm not going to write the 0, so we're just going to have 2x is equal to b minus a. So we almost have x by itself. However, we want to isolate for x. We want to keep x by itself, but this 2, we are multiplying the x by 2. So I might ask, how do we get rid of this 2? I may ask, what is the opposite of multiply by 2? What is the opposite operation? And of course, the opposite of multiplication is division. So again, I'm going to divide by 2. And very commonly, we show division using a fraction, right? 2 divided by 2. Again, this will just cancel out, giving us 1. 1x, which is what we're trying to solve for. If I divide this side by 2, I have to divide this entire side by 2. So I'm going to divide and show the fraction sign over the b minus a divided by 2 to solve. So on this side, we are left with x. And finally, on this side, we have b minus a divided by 2. And this would be our final answer for 4. All we need to solve for there. Okay, so again, we are seeing that we could solve for x or isolate for x by just rearranging variables. Again, remembering whatever we do to one side of our equation, we must do to the other side of the equation. Okay, so again, I'll do 5 here. Let's do 2 more questions together. So 5 is something like a times x. Again, we do not know what these are. Minus w is equal to 4w. Now here we see the same variable twice, and we'll find out how that affects our equation in a bit. Now again, we want to isolate for x, and I may ask, well, what is the first operation? I want you to think, what are the operations you might want to do in order to solve for this question? And of course, you could pause this video to solve for x and then check your answer, see if you did something similar to what I have done. So let's look at this. We want to get x by itself. So the first thing I'm going to do to get x by itself is get rid of this subtract w. And when we take away w, I may ask, what is the opposite operation of minus w? And adding is the opposite of subtraction, so I'm going to add w. Because we have minus w plus w, that's just going to cancel out to give us 0. If I add w to this side, I must do the same to the other side because we want to keep our equations equal. This side must always equal this side. And if I'm adding something to this side, I must add something to this side. So I'm going to add w to that side. Now here is a little different situation. Of course, our minus w plus w cancel out, giving us 0, leaving us with a times x over here. And over here we have 4w plus w. Now, I may ask, if I have 4 w's and I add another w, how many total w's do I have? And this could work with any amount of things. If I have 4 cats and add another cat, how many cats would I have? This variable is just a placeholder. So in total, we have 4 of something, 4 times something, but we add one more of that something. So in total now, we have 5 w's. or 5 times w. We don't know what w is, but we have 5 of them there. We are almost there. We are solving for x. And I may ask, well, how do we get x by itself? And we still want to apply opposite operations. If I have multiply by a, right, because when two things are next to each other, they are multiplying in order to solve for this. The opposite of multiplication is division. So I'm going to divide by a here. And again, if I divide by a on one side, I must do the same thing to the other side. So I'm going to divide by a here. On this side, we have a times x divided by a, but an a divided by an a, or 1 divided by 1, 5 divided by 5, is just going to cancel those out and give us 1, or x is our answer there. And this side we're just going to keep as a fraction. 5 times w divided by a. All right, let's do one more equation to put this all together, where we have a times x plus b minus y equals 3c. And you could pause the video to try to solve this on your own, or follow along here. So again, we want to apply opposite operations. Get rid of this b and y. The opposite of add b is minus b. So I'm going to subtract b from both sides. Again, our b's cancel because plus b minus b is just going to give us 0, leaving us with ax minus y on this side equals 3c, and I'm going to write the b beside it because we write linearly in math, to get minus b. Now let's get rid of this minus y. The opposite of minusing y is add y. So if I add y here, I must add y to this side. So again, I'm going to write plus y just over here. And we have minus y plus y. Of course, that cancels out, giving us 0. We get a times x is equal to 3c minus b plus y. And we're almost there. Again, this may look funky to you, but these are just number holders. I could give you values for this, but we want to just isolate for x, solve for x. So, and lastly, we have a times x. The opposite of multiply by a is divide by a. So I'm going to divide this side by a, that canceling to give us 1, and this side divide by a to get us here. So here we got x is equal to 3c minus b plus y is equal to a. And these letters or variables do not matter what they are. However, they are numbers. We don't know what those numbers are. And once I give you numbers, we could just apply. And this idea of rearranging formula is important in mathematics, especially going forward there. So here are 6 questions, 6 examples you could follow in order to complete the sheet I have provided. Well, enjoy.